Pero no,
Hola,
anfitrión, no me lo quite a mí, sino que se lo haga, hola, a ella. Pero no,
hola.
anfitrión, no me lo quite a mí, sino que se lo haga, hola, a ella. Bueno, lo he lanzado. No, anfitrión, no me lo quite a mí, sino que se lo haga. Vamos a ver, porque se escucha tres veces seguido.
A ella.
Momentillo, momentillo. Vale. Yo creo que es porque por YouTube. Vale. Bueno, lo estamos lanzando a YouTube ahora mismo. Hola a los que no estén viendo por YouTube, aunque todavía no haya compartido el, a mi YouTube. El enlace. Ay, de verdad, me lo pilla. Y no me lo pilla. Te lo paso por aquí, por si queréis compartirlo por algún sitio. Está el live. Ah, y grabarlo, sí, claro. Y grabarlo, y grabarlo. Y yo que comparto también. Y un momentillo todavía, un momento, Corona. Danos un minutillo más. Aunque se esté grabando, pero ahora me sale lo otro. Vale. Uy, ¿cuánta gente? Bueno, pues si quieres ve dando paso a la gente, podéis ir dando paso eh, y vamos a ver qué tal va esto hoy.
Hola.
Hola, hola a todos. Los que estamos dando acceso de los que estabais en la sala de espera.
Os
Se
saludaba
sigue.
usted. Quitar el vídeo y el audio.
Sí, 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 podéis, por favor,
Ya.
solamente no
Hola.
desconectéis, salvo que luego vayáis a hacer alguna pregunta,
Vale, vale,
en
vale.
principio
Venga,
puedo.
hasta ahora.
Vale.
Hola.
Hola, ¿qué tal? Sí, sí, no importa los que estáis entrando que no participáis, no compartáis ni el vídeo ni el audio. Gracias. Coral, tú sí lo puedes dejar, que tú me tienes que presentar dentro de un minuto.
Hola, buenas noches. Hello, good evening. It's wonderful to be here tonight under, I'm afraid, a very rainy sky. But this is what we promised, a stargazing event live of the Australian skies. And we are honored to have here with us Ángel López-Sánchez, Professor Ángel López-Sánchez, also president of SRAP, the Association of Spanish Researchers in Australia and the Pacific. It is wonderful to once again put in place an activity to promote science from a SRAP member, and as I said before, SRAP president, Professor Ángel López-Sánchez, according to the collaboration between Instituto Cervantes and SRAP that has been ongoing for several years now. It is every year we usually collaborate in mirrored activities, and it goes without saying that during this week, which is the National Week for Science here in Australia, we set or put in place a wonderful activity year after year with SRAP, sometimes in Instituto Cervantes premises, in other occasions, an online activities such as this for today. As I said before, today the goal was to have a stargazing event live, and this is what we have. It is live, certainly, but it is a very rainy and cloudy sky. But Professor Ángel López, whom we'll be starting, has a lot to show us from these Australian skies. So without further ado, the most important and interesting event is coming, will be in the hands of Professor Ángel López-Sánchez. So the floor is yours, Ángel. Once again, thank you so much for your time here tonight. Thank you so much once again for SRAP, for putting in place another wonderful activity that enhances the collaboration of Instituto Cervantes, in this case in Sydney, and SRAP to promote science from SRAP. Thank you so much.
Thank you very much, Coral, for that. I think I'm honored to be here again, to be presenting an astronomy event, which is my passion, as you know. I'm Ángel López-Sánchez. I'm an associate professor at Macquarie University. I'm currently the president of the Spanish Researcher in Australia Pacific Association. And believe it or not, as the weather is not helping, it have actually been a bit more challenging for me to try to organize this that if it would have been clear, because my idea for the event was actually to show you live the objects in the sky. So what I'm going to do is to share a presentation, and I will try to do a little trick for trying to emulate how we are observing at night. So that should be that one. And hopefully you see my presentation right now. To move myself a little there. So Stargazing Live, discovering Australians' winter sky. That was the idea for today, for this nice event. As I said, however, we cannot forget that astronomy depends a lot on the weather. And well, that was the photo I took just a couple of hours ago from the place where I was going to put my telescopes to do the stargazing. Here in Sydney, it is an horrible day, have been raining a lot. So I think that Stitch can say that much better that I can do. Yeah, that is what happens with astronomy, with amateur and professional astronomy too. Sometimes for as professional astronomer that we have to go to a telescope and we only have 1 or 2 nights for our research project, and only those 2 nights have been allocated, and it is raining or bad weather and you cannot do anything. That is the life of an astronomer, what we are going to do. Anyway, as I said, what I'm going to try for you today, this evening, it is to emulate somehow that. Let me start coming back to the presentation, discovering Australian winter sky. Perhaps let me start a little bit more about this image. This image is just a nice image from Silent Spring Observatory. That is a place where I usually work. That is at the Warrumbungle in the Warrumbungle National Park, near Coonabarabran, 500 kilometers northwest from Sydney. And that is the dome of the big Anglo-Australian telescope, and beautiful dark place where we can see many, many stars, the Milky Way, and not only that, but also the dark constellations that the Australian Aboriginal were able to see, particularly the galactic Emu, that is composed of very different clouds, dark clouds in our Milky Way. So that is when we are lucky enough to have a dark place. If we are in a big city, for example, in Sydney, well, we see stars, not many, but we still can see some few of them. And the question here it is, how can we identify the different objects that we see? If I'm telling you, okay, believe it or not, that is, there are 2 planets here and a very famous zodiacal constellation, which is Leo. Because that day, when I took this photo some few years ago, it was actually a planetary conjunction between these 2 planets, Mars and Saturn, in the Leo constellation. If I put and add the lines of the constellations, you can see the bright stars of the Leo constellation, and also can mark the 2 planets, Saturn and Mars. But in any case, if you are starting in astronomy, and that is also part of this presentation, and it was something that in any case I was going to say, regardless of the weather, how can we find our way in the stars? What is the best way of actually, if you don't know much about astronomy and how locate different objects in the sky, go outside and being able to orientate yourself and find your way in the stars. That is one of the questions, one of the topics that we are going to be talking today. The other one will be, okay, we want to observe the sky. We need instruments for observing the sky. For amateur astronomer, or if you are a beginner, I will recommend you start with your naked eye or with small binoculars. But eventually, if you like this hobby or passion, you would like to get a little telescope. And that is the other question. What telescope should we use? What kind of telescope it is best for starting in astronomy, or what kind of telescopes are there? Let's go to start with that and trying to answer in a little bit to that second question. Let's go to talk about telescopes. I could ask you, what do you think it is the main characteristic of a telescope? And I typically ask this question in many of my talks when I'm talking to the public and try to, introduce how we can observe at night and what kind of telescope should be using. And if I ask to you, and if you have been thinking a little bit about this question, perhaps you are considering, we need a lot of magnification because we want to see objects that are faint, small in the sky. But actually, that is not the main thing of a telescope. The main characteristic of a telescope, it is the size of the lens of the mirror that is used in the telescope. The bigger the telescope, the larger aperture, the more light it is able to capture. Just think about as a bucket. You want to capture the light that is coming, and if you have a small aperture, you will not be able to get many light, but if you have a big one, then you will get much more light. And in astronomy, and that is a big difference with respect to when we are using microscopes for biology or for medicine, in astronomy, we do not use much magnification, usually very low magnification. So if you are interested in astronomy and you would like to get a telescope, the last thing that you have to do is go and buy a telescope like this one. Not only because it's, it seems okay, but it's really not for that price, because not only is it small, but the quality of the lenses will be very bad, and the quality of the accessory that we put here, an eyepiece, that will be horrible, and will be very difficult to see anything. Imagine that these are classified under toys, even though if it is going to be for your kid, or it's going to be for a young person. I usually call this kind of telescopes, I'm going to say that in Spanish first, destroza aficiones, or destroy hobbies, destroyer of hobbies, because you will be very frustrated. You will not be able to see almost nothing, just the moon a little bit, and that it is. There is even a worse case, that one. Again, toys, but they're saying 50x and 100x lenses. With that small, no. Run away from this. If you really want to get a telescope, get advice. Or you go to a specialized telescope store, and there's some few in the main metropolitan areas in Sydney, in Australia, in Sydney and in Melbourne and in Brisbane. You can contact them directly, or you can talk to associations of amateur astronomers in your area, that they will suggest you the best telescope for you. Because unfortunately, buying a decent telescope that you can start to do some few things is not cheap. Even the smallest telescope that you can use for doing a bit of astronomy and really starting in astronomy, they will be at least 300, 400, 500 Australian dollars. But they will be definitely much better than just putting your money into the rubbish with the 45 or the $90. Then you have to decide what kind of telescope do you want. And there are different kinds of telescopes. There are actually many different kinds of telescopes, but we can classify them in 3 different categories. One, it is the standard one that you might think about it. It is a refractor telescope. It is made of lenses, so the refraction of the light, that is the standard telescope you think about. The light is coming from here and you look from the back. That is one kind. The problem with this, it is that they are difficult to get good quality lenses, and even much difficult to get big apertures. On the other hand, we have reflector telescopes that are, the main thing, it is a mirror. The mirror, it is here at the back. Imagine that it is an empty tube. The light is coming from the top, going to the mirror at the bottom, reflecting and going to a little secondary mirror that is just reflecting the light to the eyepiece that you look through there. These are good for starters, particularly if you, for beginners, particularly if you are in a dark place where you can see, thousands of galaxies actually, even with this kind of small telescopes. A telescope such as this one, right now, it is of the order of the $800, which is okay for a starter. There are some few more sophisticated telescopes. This one, it is called a catadioptrics because it is combining lenses and mirrors. And I'm not going to bore you about the details of this. Typically, these are much more expensive in some way. But I'm just talking about the long tube here, the long tube here, and the compact tube for the catadioptrics. You also need a mount, the tripod, to put your telescope. Some can be what we call equatorial, so they have actually not 2 axes, but 4 axes, because 2 axes are up and down, horizontal and left, right, and left. And the other 2 are just for tracking the stars. If we orientate this axis to the south celestial pole. But that is much more difficult to do. And you have to learn to do that, and can be also very frustrating at the beginning. That is why I still recommend the kind of altazimuth, which is just up and down. They are not be able to track. You cannot track the sky, although there are some few systems right now that allow us to do that. But again, if you have the motor or you have the system, something like this, it will be a bit more expensive. So you have to have all of those things in mind. So the setup that I have for tonight, or I will have for tonight, it is this telescope that I want to show you, the different parts of it. Because once that you are into astronomy and you also want to get images and not only look through, but also getting images, then you need a much more complex setup. You don't only need your primary telescope, but you also need a camera. In this case, we will have a cooled astronomy camera. We will have the mount, a heavy mount that is able to track the sky in some way that the object is always in the same place in the camera, in the chip of the camera. We need a small telescope with a little detector, a guiding camera, in order that we can correct a small variation of the tracking. A filter wheel, because in astronomy, typically we use black and white or grayscale, put filters. If the weather can be condensation, then we need some heaters, the dew heaters, to avoid that in the lenses. A computer for controlling everything. So it can be quite sophisticated, and it is, a curve to learn to do that. That would have been one of the telescopes that we have been using today. The other telescope, it is another one that I recommend a lot right now. It is a brand new kind of telescope. It is a robotic telescope. It has always advantages and disadvantages. Right now, this small telescope, which is a refractor telescope, a small one, but robotic. I think that the cost right now, it is around $800, $900. But you cannot look through it. You have to use a device to connect to it, and you will get the images through the device. So it's not exactly you are looking through. So it's something different. However, you can do many things even in the cities. And I will show you some few examples. That is the telescope I have here on the back. That is the one also that we will have been using. One telescope for observing one kind of objects, the other telescope meanwhile tracking and looking for the different objects. As I said, these are brand new. These telescopes were released late last year, and I was lucky enough to be able to get one at the very beginning, and I have been using it extensively, this one, because it's really, really, really good, particularly for beginners. So that is the first part. Now you know more or less what is the telescope, what kind of telescope do we have there, but then the other part will be orientating us in the sky. There are many ways of doing that, including apps, and I will show you an app later. I still recommend a lot for beginners just going to skymaps.com, to this website here, and download the monthly map of the sky. In this case, for August 2024 in the southern hemisphere. That is a very good way of starting, because in the moment that you have the app, you start zooming and unzooming, and you don't know well the scales. So I still, perhaps, I don't know if it is because I'm still, old school, and I find, and still the experience I have with students, it is that they are able to understand much better how to orientate themselves in the sky using this kind of map. This map, what is it showing? It is all the sky that is visible at early August around 8 p.m., late August 7 p.m. So it would have been something like 7:30 p.m. by now for us. With the 4 cardinal points: north, it is up; south, it is at the bottom; east at the left; and west at the right. And with this little cross that you see in the center, that is the zenith. That is the point just on top of us. So you can use this for finding the main constellations that are these drawings with the names of the main stars. For example, Altair, Vega, this R, and the Nep is already hidden, so this will be 2 bright stars. More in the center, close to the zenith, it will be Antares in the Scorpio. So you can use those for orientating in the sky. In the back of the page, because it is actually a PDF that you can print into different into pages, it provides a lot of extra information about celestial objects, tips for observing the night sky, a glossary that we use in astronomy, and in the right-hand side, you have actually something that sometimes can be extremely useful if you are starting astronomy. It is knowing what kind of objects are there that you can try to observe with your naked eye, with binoculars, or using a telescope. So these are actually very convenient for starting. On top of that, you probably have realized that there is a sky calendar here on the left-hand side. For August 2024, different events, astronomical events that are happening during the month. For today or tonight, the 14th, the moon will be near Antares. So I already mentioned Antares, which is the brightest star, red star in the constellation of Scorpio. We will see the moon around there. We will have seen the moon around there. And later in the early morning before sunrise, Mars and Jupiter would have been very close together in the sky, in the morning sky. But we cannot see that. Let me show you at least some few images of what we would have expected to see using these telescopes at the moon. That was an image that I took last week for another event that I was organizing using this small telescope that I have in the back. And really, perhaps for starting in astronomy, going to the moon, it is the first thing that you have to do. Even though later, when it is almost full moon, we want the moon out of the sky because it is too much light for observing faint objects. At the beginning, you want to go there. You can be lost just finding your place and your craters and your mountains and your terrains and your different features, many features in the moon. You can see absolutely many details, even with a small telescope. Even with the toy telescope, but the toy telescope will be kind of rainbow because they will have very bad quality. Of course, depending on the day of the month that you're observing the moon, you will get different views of the moon because of the different phases of the moon. This was actually, this image, it is a mosaic of 8 different images during the different phases of the moon that my son and me took some few years ago. when he was still in year one, so that was when he was 6 years old, for him to try to understand better how the moon was moving around the Earth, and how, because of that, that is the consequence that we sometimes see illuminated in one side or the other side. He was later very famous at the school because these images were used for the pocket guide to the moon by the ABC, that is still there, just celebrating the 50th anniversary of the humans getting to the moon. And he was very happy, to have his name ported there. So someone who was able to provide material for this website and this pocket guide, and the images were also used for in science museums here in Australia and in Spain, and have been in several books. So that was a good idea for motivating the kid to do something else that is a bit using the screens, but in a good way. Let's say that way. Of course, you also need a map of the moon if you want to start observing the moon. There are many features, and these are only some of the brightest or the most famous one, starting with the different mare. The mare are just the seas of the moon, regions that are the lower regions of the moon, very different to the highlands of the moon that are very craterized, have plenty of craters. And some of the mountains, the Apennines Mountain, the Caucasus, the Sinus Iridium, that means the Bay of the Rainbow in Latin, and some of the very bright craters, for example, Copernicus and Tycho. These are two that are very bright, and these will be particularly the ones that we'll have been able to see this evening. And that is more or less the image of the moon that I would have expected for tonight, with Copernico and Tycho being very evident, this impact crater, recent impact crater. That is why we can see the debris from the collision still going quite far away. And still, let me emphasize that we are using not much magnification here, only 35x or so. With the moon, as it is bright, you can put much more. You can go to 100, even 200x, and you can see only a tiny region of the moon with plenty of detail. It's really fantastic. So that would be the best way of starting, perhaps in astronomy and observing our neighboring satellite. Okay, so one moment, because we have someone doing funny things. Just sorry for that. I think that someone that should not be there was there trying to, to be messing with the presentation. Okay, let's continue. The other important feature that I would like to show, and that you have to recognize in the sky, well, you cannot see it, of course, but you will identify this place. And wait, I'm not sharing. Go back and share again. One sec. That is what I was saying. The other feature that, as I was mentioning, it is very important that you identify in the sky, but again, you cannot see it because it is just that dot dash line, which we call the ecliptic, that is the path of the sun as we see from Earth. And you will see that it is crossing interesting constellations that probably you know: Virgo, Libra, Scorpio, Sagittarius, Capricornio, Aquarius. These are the zodiacal constellations. So this is important, not because of astrology, don't maybe go into zodiacal signs or whatever. It is important because we are going to find planets around that area on the sky, around the ecliptic, because all the planets in the solar system move more or less in the same plane. So they're going to be around there. So if you pay a little attention, or you perhaps have realized, there is a planet that is rising from the east at the moment, which is Saturn, the Lord of the Rings. So that will be the main planet that we will be able to observe, not right now, and it will not be possible for us to observe it right now because it's still very low over the horizon. You need to wait a little bit, 3 hours at least, to have it high in the sky and observing much better. But definitely by 9:30 p.m. local time in Sydney, we will have been able to observe it. Here it is when I have to give another warning. In the same way that I mentioned that observing the moon is fantastic, people who are new to astronomy and to observe using telescopes sometimes are very disappointed when they are looking to the planets. Sometimes they're not, also very excited. Because we are familiarized, because we are used to these beautiful images taken by the best observatories in the world or by a spacecraft that have been actually there in those planets and provide a lot of detail. But that is not what you will see with a small telescope. You will see the bands of Jupiter with the satellites, and that is actually changing a lot. You will see Saturn and the rings, even the Cassini division between the two main rings. That's kind of black thing in the middle. You will see that. Mars, you will not see much. With a bit of luck, you will realize, you will see that it is very red, and there is an area which is a little bit white. That is the pole, one of the north or the south pole, and some brightest, darkest area, depending on whatever you're looking at. So don't expect to see very bright planets. The planets as you see in the photos. Of course, if we are able to get a good equipment and obtaining a photo, even with those telescopes that I was showing you, the telescope, for example, that I showed you before, you can get nice images when you are processing them. Jupiter, you will see the great red spot and the different layers of the atmosphere. Saturn, different layers also in the atmosphere and the rings, and you will realize that there are actually many rings. These two beautiful images of Jupiter and Saturn, and by the amateur astronomer Andy Caselli, who lives here in the Blue Mountains, and he is actually one of the best astrophotographers of planets in the world. And Mars, with a big telescope, then you will be able to see some few more things when the planet is nearby to the Earth. That is not always the case. That is an image that my colleague Adam Jones got at Macquarie Observatory a couple of years ago. But this year, if we were able to observe Saturn, we will see that the rings are almost edge-on. It will be something like this one here, like this image here. Because in the same way that the Earth has seasons, the rest of the planets also do have seasons. And the seasons in Saturn are very peculiar because depending on where the planet is with respect to the sun, we will see very well the rings, or we will not see the ring at all. Actually, there is a moment in which they completely disappear. That is the worst moment to observe Saturn, unfortunately. But anyway, and right now we are moving into the fall equinox 2025, fall equinox for Saturn, not for us, for Saturn. So that will happen in 2025, and that will be the moment in which the rings will almost disappear, basically disappear from our perspective, because they're extremely thin. They're really, really thin when you compare to the length of the rings. Okay, what else do we have here? So there is something else that I wanted to quickly show you, because perhaps, and particularly as many of you are from a Spanish background, and you have heard from people in Spain particularly, but people in the Northern Hemisphere talking about the Perseid meteor shower peaks, the Perseid meteor shower that was a couple of nights ago, the peak of it. And that is the kind of event that is difficult to see in the Southern Hemisphere because Perseus is just a constellation of the Northern Hemisphere. And it's very famous in the Northern Hemisphere because you can see many meteors in just several minutes or particularly in an hour. Don't expect to see something like that. I wanted to show you this beautiful image that was astronomy picture of the day of NASA just a couple of days ago because it is nice. Yeah, you are seeing Stonehenge and many of the meteors of the Perseids, but that is combining photos during several hours. Okay, you are not going to see that in the sky. It's very rare, but you will be able to see one shooting star every, I don't know, 2, 3, 5, 10 minutes. At least you will see something. Something else that you can learn in the sky. Let's move a little bit further into the stars and into the position of one of my favorite positions in the southern sky, which is that region here, the Southern Cross, Pointers, and Carina. And that star there, it is Alpha Centauri, which is at 4.4 light years from us. Sometimes it is said that Alpha Centauri is the closest star to the Earth. There are two things that are wrong there. First, the closest star to the Earth is the Sun. So it will be the closest star to the Sun is Alpha Centauri, but not quite. That is the star that we can see, but actually there is another very faint star which was discovered in the 20th century, in the beginning of the 20th century, which is a red dwarf star called Proxima Centauri, which is a bit closer to us, 4.2 light years from the Sun. But well, you are seeing stars as they were in the past. Remember that we are seeing the past every time that we are observing astronomy. Gagrux, for example, which is a red giant star, the top one of the constellation of the Crocs, which is this one here, that is at 89 light years. That you can compare with Acrux, which is at the bottom of the cross, 322 light years away. And Hadar, which is another but it is a blue giant, that is located at 390 light years away from us. So that will be a good moment that we can try to do a bit of stargazing. And I'm going to do this only once because I need to swap to the iPad in order that I can show you another way that we can use for recognizing things in the sky, that is using the app. And there are some few apps, but screen start broadcasting, so hopefully that will be doing very quickly. Why? Sec. Let's see if now it's working now. There we go. One of my favorite applications. Application. Why it is not? I have to repeat. There we go. One of my favorite applications, it is Sky Safari. You can move around very easily and find whatever you want to observe. Remember that I mentioned before that and the moon was going to be very close to Antares. You can see that there. You can actually see also more or less the face of the moon. Not they don't have the features, identifying the features, but at least you can see how the moon is right now. And this application, this app, I can use it to connect to my telescope. That will be the field of view that we have for that telescope. Let me go to the region of the sky that I was mentioning before, Alpha Centauri. See? So I can send the telescope there, if it were clear. That is the little box of the field of view of the telescope. And my surprise for you would have been that if we do a little zoom in here, and we pay attention to this star, it is actually two. It is a double star. These two stars are really similar to the sun, more or less, the same size and the same mass, a little bit more massive, and just that is all, and the same luminosity of the sun, the same temperature of the sun. And with a small telescope, you can see that it is double. There are many double stars in the sky. Okay, let me go out again. So there are many apps that you can use. As I said, that is the one that I like, Sky Safari, but you have to pay for that. There is another very good one that is free, that is called Stellarium, that you can do very similar things. So it's really, really, really nice to have also this kind of apps in order that you can learn a bit better where you are in the sky. Let me stop sharing here. And go back to my presentation. Okay. Kind of stopping the presentation. So that is why I think I will not do that anymore, because it is taking a bit too much time. Let me put again the presentation running. Like this. Now I can share the screen again. Go. Okay. And that is an image that I took some few time ago of the double star. It was difficult to actually get that image because they are a bit too close together, and you need to put a bit more magnification to get to see them. But something important that you perhaps are starting to realize, it is that the stars have colors. They have different kind of colors. And let me tell you a little bit more, because it is basic astrophysics. Why is that? Why stars have colors? Remember at the end of the day that we have a star like the sun, 8.3 light minutes away. So what we see in the sun happened 8.3 minutes ago. And the sun, we can compare with the Earth, that little point in there, around 1.1 million planet Earth will fit inside the sun. And in the core of the sun, we have nuclear reactions happening. In the way that hydrogen, it is combining together to form helium, the easiest element to the second easiest element in nature. And that is what is creating a lot of the radiation and the energy of the star. And that is why we see them shining. However, the sun, even though we think it is big, it is not that big. And there are many other stars out there that are not only much bigger or sometimes smaller, different sizes, but also different colors. And in some way, there is a kind of a connection about the different kind of colors and the different sizes of a star. What I'm trying to represent here, it is perhaps one of the most important diagrams that we have used in astronomy for the last century, perhaps a little bit more. That is showing in the horizontal axis the color, blue to the left, yellow more or less in the middle, red to the right, and the brightness in the vertical axis. So if you go up, it will be much brighter than these stars that are here more at the bottom, the red dwarf stars. The important point that I wanted to show here, and this, as I said, this is schematics of a very important diagram that we have been using in astronomy for a lot of time for understanding not only stars but galaxies. It is that the color, it is related to the temperature of the star, the temperature of the surface of the star, in the way that the blue stars are hot and typically young, and the red stars are cold and relatively they are quite the old stars. That is when I try to make the joke that an astronomer, I'm always confused when I go to open the tab, because for me, for an astronomer, blue is hot and red is cold. But anyway, that is a very bad joke, but just for you to realize that when you see the colors of the stars, if you see red, it is a cold star. If you see white, it is an intermediate, not very cold, not very hot. And if you see a blue star, that will be a hot star. The first person to actually realize that was Cecilia Paynes, that in her PhD test in 1925, she uses the very beginning of the quantum mechanics to explain the different features that we were able to observe in the stars and the colors of the stars, and realized because of that, that the stars were made of hydrogen and helium. For many of us, that is the real birth of astrophysics, and it was made by a woman that we have to provide the recognition that she deserves, because this have been not well known till only a few years ago. So again, if you see different colors of the stars, you are seeing the different temperature of the stars, and you also know if the star is more or less young or old. Let's go to do something different now. Let's go to this object around here that is inside a star in this image, but actually it is the jewel box. It is a star cluster, 6,400 light years away from us. So now it is when I'm going to use the other little thing, and I'm going at least with this one to simulate using the telescope I have in the back to go to the object that we are going to observe. So this kind of robotic telescope, you can connect it directly to your little devices, your iPad or even with your phone, not to the laptop, unfortunately, unless you have a very complex setup. Compact and easy to move, and automatically it is clever enough to find its own way in the sky with some refinement. So right now it is trying to go there, to try to go to this object. That is what I wanted to be doing actually during the night for you, but unfortunately we couldn't do that because of the weather. But I can show you or try to reproduce what we will be able to observe. Because this telescope and many of these new devices that we are putting in our telescope, in amateur telescopes, they are starting to be very clever. And what they do, it is taking short exposures, only a few seconds, in this particular case, 10 seconds, and give you a hint of what it is there. But that is not the end of it. It is that it will keep taking images and stack them continuously. So that is the jewel box, just 10 seconds. That was an image that I obtained in April, just doing some tests here from my backyard, from the place where we were going to have the telescope. 3 minutes. So we have integrated 6 times 3, 18 images to get a much better quality. You start to see, for example, that the background it is much better, that the image is starting to come nicer, but you keep going 9 minutes and you start to see the different colors of the stars, 13 minutes, and then you realize that there is something very interesting in this star cluster. This star cluster all the stars have been born together. They're still relatively young, all of them. That is why the color is majority blue. But perhaps you have already realized that here in the center, there is a red star. That is actually the reason someone put the name of the jewel box, because it was the ruby in a box of many diamonds or something like that. That is a giant star, a star that have started to evolve into a red giant. And that was particularly very interesting. And you can actually see the colors if you look through a telescope. You can see the difference. It's very difficult to see colors in astronomy, but the contrast in bright stars, if it is a blue star and red star, you will see the difference. You will see that they have different colors. As I said, the jewel box, it is in that area there, and that is an open star cluster, young stars that have been born together, and they are part in the Milky Way. Now we go to this object here, which is Omega Centauri. It is not a star. It is a globular cluster. And not only a globular cluster, but the largest and brightest globular cluster that we know in the Milky Way. It is around 17,000 light years away. So we will have been moving also the telescope to that particular cluster. The first image would have not been much, particularly because of the light pollution in this object can be a little bit fuzzy, but we will continue going, integrating, enjoying our time. And 55 minutes later, and that was the image that I took the other day, just 8 of 8, so just last week, you can realize that this is a giant ball with many stars. Don't try to count them because there are around 10 million stars in this globular cluster. And even we are in the city, or we are close to the city or in rural areas, we can actually see this object. We can see with a small telescope, and we can definitely see with this very small compact telescope. Of course, if you do your right work and you process the image correctly, you will get even much better detail. There are some few other features that we can identify the area. For example, the Cold Sack Nebula, which is the peak of the Mu in the sky, and that is just a cloud of gas. And in that area here, it is another of my favorite objects, which is the Carina Nebula. That was an image that we took of the center of the Carina Nebula with the very bright Eta Carinae star, that star there, that is a very massive star, around 200 times the mass of the sun, that it will probably explode as a hypernova soon. Soon in astronomy is in the next 100,000 years, perhaps even a bit earlier than that, we don't know. But we start to see the nebulosity of this object because it is nebula, it is just gas glowing because of the effect of the stars. Again, if we can go and process a bit better the data with the telescope that is using my other telescope, we will see much more the details of the gas and the stars. In this image, we see too many stars because that is in the very rich area of the Milky Way. I later processed another set of images just using special filters in order that we can see much better the gas that is there in the nebula, which is right amazing. I'm still amazed that I'm able to do and obtain these kind of images just from my backyard in French's Forest, 13 kilometers from the city center in Sydney. There is nothing else in the sky that I would like to emphasize, particularly in this time of the year, because it is one of the reasons why probably this is the best time of the year for observing the night sky, which is this region that you are observing, this blue path, that is the Milky Way, that is our galaxy. If we are in a dark place, we will be able to see something like that. That is an image that I obtained a couple of years ago, combining many different images at different angles of the projection of the disk of our Milky Way galaxy into the sky with the bulge, the center of the Milky Way around here. Believe me that it is one of the most magnificent views that you can have in your life, I will say, that you are able to see that in a dark place in Australia. at the beginning of the night after sunset and it is dark, without moon in Australia and in the southern hemisphere. If we do a little zoom in of that area, I would like to show you a couple of very nice objects, nebula, that are in that area here. Let me show you again. Coming around that area here, you see a couple of nebulosities there. Doing a little bit zoom in, you see the two of them, the famous Lagoon and Trifid nebulae. Let's go first to the Lagoon Nebula. Again, plenty of gas. That is a 4,300 light years away from us. All these stars that you see, the young stars around here in blue, have been born recently in the last 10, 20, 30 million years from the gas in this nebula. We will be able to see something like that, but not the colors. If you're looking through, you will, for nebula, you will not see the colors. You will see the diffuse gas, some kind of the nebulosity. That is why they have that name, the nebula. And moving the sea star to the Trifid nebula, again, doing the kind of same trick. At the beginning, we get a very noisy image, and actually I have to stop integrating because we had a satellite crossing the field of view. That trail, it is actually a satellite of the many satellites that we are trying to have out there crossing. So that is why now it is a bit outside. 12 minutes, I start to see the different colors, and 20 minutes that you see a bit more. So the difference in colors in this nebula, it is this gas in the red gas, it is glowing by itself. It is a consequence of the very bright star here that is putting light into the nebula. But a bit more fainter, much more fainter and difficult to see, bluish, greenish color here, it will be blue because that star doesn't look like, but it's actually blue, and it is illuminating the surrounding gas. Perhaps that is a better image to try to explain that, again, using the other telescope, not the robotic one, but the other telescope. If you are using professional telescope, we can go even deeper and obtain even more details. And right now, even amateur astronomers are doing something like that. Very nice. We are almost finishing our travel in the sky for this evening, but let me show you some few other objects that are not in the Milky Way, are not in our galaxy. We can start with the Magellanic Clouds, these two clouds, blue clouds that you see around here. These are actually independent dwarf galaxies around the Milky Way. The Large Magellanic Cloud, it is located at around 158,000 light years away. The Small Magellanic Cloud, it is almost 200,000 light years away from us. And they are forming a lot of stars. They have plenty of regions. The most important one, the star-forming region 30 Doradus, of the Tarantula Nebula, that is that thing there, that using my telescope, the other telescope, and with a special filter, you would have been able to see something like this, all the glowing gas in there. Very disrupted because there have been plenty of supernova explosion. It's a very intense star-forming region in the Magellanic Cloud. If we're at the distance that the Carina Nebula is, it would have been much bigger than the whole constellation of Carina. And finally, I can also show you some few galaxies that are even farther away. With this small telescope, we can see hundreds, thousands of galaxies. Some of them are really, really nice. For example, a spiral galaxy N83, that is 16 million light years away. You will be able to see that kind of fuzzy thing, even if you are in a dark place, with an aperture, a telescope like the Dobsonian telescope, the big telescope that I showed you before. Using professional astronomy, we can get even deeper and see, well, how these galaxies are made of. Well, blue stars, meaning young stars, star-forming regions. The stars in the center are red, meaning they are mainly made of older stars. The black parts it is the dust in the gas in the galaxy, the same way that I was showing you the EMU in the Milky Way. that was a face-on galaxy. There are some galaxies, spiral galaxies, that are edge-on. A famous one, it is the Sombrero Galaxy, and that is again an image of a galaxy, this galaxy that I took from here, 28 million light years ago, years away. Of course, using, for example, the Hubble Space Telescope, we will see much better how the disk that is almost edge-on of the disk of M104 is. Let me just finish with this image of the Centaurus A galaxy, which is a mix between the two of them, between a spiral and elliptical. That is with the sea stars from Cunabarabrand, from a dark place, where I was really amazed that we were able to detect even external parts of the galaxy. That is with the same galaxy was with the other telescope that have much better quality and have been much better processed. That galaxy, it is only at 11 million light years from the Earth. But at the end of the day, what I have tried to show you today, it is that the sky is there for you to discover. You can use a small telescope and really see things that not many people have seen, and even discover things out there. But the most important thing at the end for me to emphasize it is that you have to enjoy observing the night sky, because you can learn many, many things, and also appreciate much better the things that we have here in our planet Earth. And I will leave it there. Thank you very much for attending, and I will be very happy to answer the questions that you have. I see some, you have put your video, so you want to unmute yourself. You can say hi, and if you want to ask a question, go for it.
Yeah. Oh. Oh, no, like
Yeah.
Is it possible to see a constellation without a telescope? No.
Yeah, I think that there are two of you talking at the same time. Please let me mute here. I'm going to mute. And Yamundu. So
Yes.
you were first. So you want to ask now.
Okay.
Yaman.
Is it possible to see a constellation without a telescope?
Actually, the only way of observing constellations is not using telescopes. Constellations are big areas of the sky that are for our eyes to see. So you cannot see constellation with a telescope. Constellation, at the end of the day, are made at figures that we have identified. Okay, that star with that star with that star. It seems that is a cross. That might be a cross. But other cultures actually have identified different figures in the stars. There is a game that sometimes I do with students or your age. That is, okay, I'm going to give you a sky map without any kind of line. Find your own constellations. And this will be the constellation that you will see by yourself. Officially, by the International Astronomical Union, there are 88 constellations in the sky. So all the sky are divided in these 88 constellations. But you don't need a telescope. You cannot see the constellation with telescope. You have to use your naked eye to recognize them. Okay?
Thank you.
Thank you. So who is next? Carolina, I think you were next.
Hey.
Hello. Yeah, asking you to activate the audio, and you want to ask.
I want to.
Hello. There you are.
How many stars
Hello.
in the solar system? In our solar
How many stars in the solar? How many stars do you think we have in our solar system? Can you count how many?
No. 2007?
No,
2007?
in the solar system. No, only one, the sun.
Oh.
The sun is the only star of the solar system.
Oh, yeah.
We have to distinguish the solar system from the Milky Way galaxy. The Milky Way galaxy have between 200 billion to 300 billion stars.
What?
But that is a completely different thing.
Uh-huh.
The solar system only have one. But for example, the star that I showed you, Alpha Centauri, that system have not two, three stars, because Proxima Centauri belongs to the stellar system. And there are many stars out there that actually not one, but two. Thank you. So who is next? I think
There's a question in
I'm
the
asking-
chat.
Dogs.
yeah, I'm asking, I don't know who are you, accounts,
There's a question in the chat,
maxlabel.com.au. Yes, there is a question in the chat.
Is there any
which-
website or way to know when it will be a good time to see Aurora Borealis?
Okay, Aurora Borealis, it is impossible to see from the southern hemisphere. Sorry, I'm just messing with you. Aurora Australis is what we see in the southern hemisphere. And Aurora Australis in Australia is very difficult to see. Very, very difficult to see. Even though we are right now in a good moment to see auroras, that would be a kind of a long explanation. The point at the end it is that although the closer you are to the poles, to the North Celestial Pole or the South Celestial Pole, the easier it will be for you to see an aurora if that is happening. But the geographic North Pole and the magnetic North Pole are not in the same place. So they're actually not in the poles. They're a little bit in the other side. And for Australia, it is actually a bit farther away, much farther away than being actually in the South Pole, geographic South Pole. So it is difficult. It can be only possible to see the very bright auroras we had in, I think it was in May, early May, in Tasmania and in the south coast, very south coast. Some people, they think they have been able to see from rural New South Wales just a reddish color, but that will be not the very impressive auroras that you can see. You go to places like Canada, of Iceland, of Norway, or Finland, or some place like that. There are websites for checking that, but again, they are the best one are the NASA ones that are in the US, because they are not only for America or the Northern Hemisphere, they are for all the world. Another question. So who wants to ask the question? Pazuela Palacios, I have your hand there.
I got one question. Do you know what J4107b is?
Wait a minute, sorry.
What?
J4107b. J4107b is a brown dwarf that has the largest rings ever. It's about 120 million miles wide, and it is true.
Well, it can be. There are many brown dwarfs out there.
Yeah, its rings are 120.
But these are objects that are extremely difficult to observe, even with small with this kind of telescopes. They brown dwarf are the kind of frustrated stars that were not bright enough for containing the nuclear reactions I showed you in the image. And of course, remember that there are trillions of objects out there. It is almost impossible to remember the very peculiar and particular ones. But yeah, it can be a very interesting object to analyze, but not using this kind of techniques. So brown dwarf are impossible to see using small telescopes or using for amateur.
There's another question I also have. How to find it? The name of the star is V144 Centauri. That's how you find it, known as J for 107. You can't really see it.
Well, that would be it would be a faint start probably to see. Remember that, as I said, there are at least there are more than 200 billion stars in our Milky Way, and many of them, and actually many of them are very faint, not only far away, but faint, and only using professional telescope we can see them. The stars that we only see in the night sky, the ones that I was showing you, they're relatively very close. They are, and they're also the brightest. Remember that even I told you, the closest star to the sun, which is Proxima Centauri, a red dwarf star, it is the closest to the solar system, and it was not discovered till the 1920s because it's really, really faint. And they're also the brightest. Remember that even I... Someone have debated. Okay, if you have any more questions, if not, I don't want to bore you with more of my chatting. Again, feeling a bit bad that unfortunately we were unlucky with the weather, although I hope in some way I have been able to show you how we play in astronomy and motivated you to do a little bit of amateur astronomy. I have two more hands, so I'm going to ask perhaps the last questions.
And
Yamandu.
if that's okay, so that it's not.
And yes, and you too.
Okay,
go for it.
You had an image that had
Yes.
two stars that were glowing, like red and blue together. I can't remember what the name was. Does that mean it's... Yes. Does that mean it's one is a young star and an old star next to each other? Because it's blue
in
and
some
red?
way, yeah. In some way it can be, but I think that when you are mentioning it is the jewel box, there is also something that I didn't tell you, because then we will start talking a little bit more. Stars, as they evolve, they can change color, and all stars eventually will become red stars because they will inflate, they will convert in a red giant star, and because of that, the temperature in the surface will drop, and that is what is making that they are red. And the way that stars evolve is very interesting, because the more mass a star has, the quicker it evolves. So when you have a star cluster like the jewel box, that all the stars have been born together, they have more or less the same age. Everyone have been born at the same time. But they have different masses. Some of them are more or less like the sun, the same mass of the sun. Many more will be smaller than the sun, and some few are much more massive than the sun. And the most massive of them in that particular cluster is already in the phase of going into the red giant. And that is why we see that it is red. In this case, it is not the age. So that is also why they say tend to be, or used to be, because when you are comparing these kind of objects that are in the same cluster, they have been born more or less at the same time. What we are seeing, it is the evolution of the stars. And that is also why it was so interesting for astronomers to see an object like this, because we can observe different phases of the evolution of the stars, knowing that they are in the same distance. Knowing the distance is very tricky in astronomy too, and that they have been born together with the same chemical composition, the same age, and the same properties. So that is why it was so interesting to see something like that. And you can see the colors. You can really see the colors.
Okay. Tenemos una última pregunta. We have a last question, if that's okay, in the chat. And we finish it at that because it's more time than was allocated. But I would like to remind everybody the video is in YouTube right now in Ángel López. It will also be downloaded for in the SRAP, I think, and also in the Instituto Cervantes YouTube channel. The last question to wrap it up, if that's okay, for this wonderful presentation would be from Gabriel. He's asking, what would be the most impactful night sky, the northern or the southern hemisphere?
Thank you for that. No, what are you doing? No. Sorry, my telescope did something funny. It's very easy for me to answer that question. Definitely the southern hemisphere. The southern hemisphere is much richer than the northern hemisphere because we have the center of the Milky Way and the majority of the Milky Way in our southern hemisphere. That is why it is really, really impressive to see that in our skies.
Muy bien. Pues muchas gracias. Thank you so much, Ángel. We combine English and Spanish. This has been a wonderful rainy sky insight, a wonderful stargazing for adults and for children. And as Ángel says, it's about time that we start to acknowledge what we have, maybe even looking a bit better or in more detail our sky. So the last few words, if you'd like, Ángel, and we can wrap it up. And I remind everybody that this will be on YouTube channel from Ángel López, perhaps also SRAP, and definitely also in YouTube channel from Instituto Cervantes. Thank you, everybody, for being here tonight with us, admiring the Australian sky.
Thank you very much, Coral. I really want to emphasize again that it is great to continue collaborating with the Instituto Cervantes, the SRAP, the Spanish Researchers in Australia Pacific Association, and myself personally, in order that we can try to run events like this one and many other kind of activities that we have been doing together, and inviting people to also to participate in next events that we will be organizing. And definitely, if really observing the night sky, it is much easier than what it seems, and it will provide a lot of satisfactions. I will say, and so you can enjoy to observing the night sky and discovering objects by yourself. Thank you.
Buenas noches. Muchas gracias, Ángel. Thank you so much.
Thank you very much to everybody.
Bye.
Bye bye.